So we want a word bank, maybe? How many did you get right without the word bank? Hold up. Do you know one of them, two of them, three of them, or four of them? How many do you know of those symbols? Hold up with your fingers. 0. Okay, thank you. 1, 0, 0. Okay. So let's get ourselves a word bank here. There we go. Here's your choices. Ray, parallel, perpendicular, congruent. And those are your 4 choices. So see if you can match those up. Nate, what do you think number 1 is? Parallel. Very good. If you all got parallel, you're correct. Very nice. Paige, what's number 2? What's the symbol? Yeah, you got it. Congruent. Perfect. That might be new or might not. It's like an equal sign with a squiggly on top. Elijah, what do you think about number 3?
A ray.
Yes, very nice. That is a ray. It's not a line, it's not a segment, it's a ray. And Alexa, last one, number 4. What's that word? Perpendicular, that's right. Everyone say perpendicular. Oh, that was not loud enough. Everyone say perpendicular. That is a major player in our unit. I'm writing parallel. P-E-R, P-E-N-D-I-C-U-L-A-R. That's a very long word. All right, so keep that out because we're going to have an exit ticket in a minute. But what we're going to do next is we're going to do presentations over word, point. A location in space that has no thickness or size. You don't have to write the definition. All you have to do is draw the picture, put the notation, and then put a real-world example. So this box is always going to be the picture. This box is the notation. You name it with a capital letter. No lowercase letters for points. They're specialer than that. They get capital letters. And then the real world example, you can say a house in a neighborhood, you can say a doorknob, you can say the tip of my pencil. There's all different points that you could name for a real world example. All right. Did you see what's on that t-shirt? What does it say? Ha ha ha. Get it? Like there would be no points if we didn't have geometry. Because that's one of the basic terms of geometry. Life without geometry is pointless. Okay. Who had line? Okay, so the next word on your list is line. L-I-N-E, line. We see them everywhere. A series of points. Did you know that a line is really just a series of points? It's just a lot of dots connected. Did you ever do connect the dots when you were growing up? Connect the dots? Yeah. A line is just literally connecting the dots. Series of points that goes on forever in 2 directions without end. The picture, that's line BC. That's a picture. It's like a diagram. And then the other one is called the notation. When I say notation, that might make no sense to you. What that means is that this, if I were to write a sentence, that's how I would write line BC. I wouldn't have to write all these letters, line BC. I could just put BC with a line on top, and everyone would know that I meant line BC. Okay, here's a question. Is line BC the same as line CB? If you think it's the same, give me thumbs up. If you think those are different lines, give me thumbs down. Are those the same line or different lines? Thumbs up is correct. Those are the same line. So guess what? When you're naming that line, the order doesn't matter. So you can't get it wrong. You can call it BC, you can call it CB, because either way, it's the same collection of points. Because all a line is a collection of points. So I want you to think of a line as this. Lots of little dots that when you put them all together, and they go on forever, they form a straight line. All right, point lines is plane, P-L-A-N-E, plane. Not like plain Jane, because that one has an I in it, right? Plane like an airplane. A plane is a flat surface that has no thickness. We didn't go over a real-world example for a line. What'd y'all put?
Never-ending road.
A never-ending road. Cool. I mean, all roads do have to end, but let's pretend it never ends. Yeah, or in like a story or a book. Supposed to be a line. I mean, everything that we give an example of, it's really going to be a segment because nothing really goes on forever. But like a meter stick, you could say that that's a line if it went on forever. Now, to name a plane, I'm just warning you, there's two different ways that you could name a plane, so it's kind of confusing. Most of the time, we're going to name it with 3 capital letters, plane A, B, C. But every now and then, sometimes, someone might name it with 1 italicized letter. What does it mean to be italicized? Have you heard that? Remember, like when you're in the Word document, there's bold, and there's underlined, and there's italicized. What does that mean? It's like slanted. It's kind of like cursive. So we could also name this plane slanted P. But normally we're going to name it plane ABC. We're going to pick 3 points, and that's how we're going to name the plane. Okay? Flat surface that has no thickness. I also want you to put that this one, like I was asking earlier, it goes in all directions. It doesn't go in one direction. It doesn't go in 2 directions. It extends in all directions. So what would be a real-world example of a plane? What? Ceiling. Thank you. I passed out some ink back. Ceiling. A piece of paper. What else is a flat surface? The grout.
Grout.
Oh, I was about to say the grout would be a really good example of a line. The ground, yes, but the grout could have been a line. Okay, very good. All right. Moving on. Next word is space. Wait, Miss Dan, you forgot the pictures. Well, I can't draw a picture of space. And I can't draw a notation for space. Because space is simply the set of all points. That's what it is. It's kind of weird. It's a weird concept. It's like everything that ever has been and ever will be, that is space. So there's no picture. You can't draw space. I'm not even just talking about outer space. I'm just talking about all the worlds of the universe. All the points in the universe. And so space is simply the set of all points. So that one's kind of a weird one. All right, who had collinear? No one had collinear, someone had coplanar. So collinear, everyone say it. Collinear, because I hear all different pronunciations of this. Collinear are points that lie on the same line. Yep, points that lie on the same line. So I want you to think of collinear as meaning same line. So co means same, and linear sounds like line. Collinear, same line. So I drew a line with 3 points, and then I said, hey, all 3 of those points are on that line, so they are collinear. What does it mean if 2 people are co-workers? What does that mean? They work together, like for the same company, for the same building. And so co-workers work for the same company, so collinear means same line. Do you see the word line and linear? Did y'all catch that? Same line. So if you forget what collinear means, just think of co-worker. It means same. They're working together. These are all co-workers hanging out on the same line. What would be a real-world example of collinear? Ooh, that was tough. A real-world example of collinear. Yeah.
Where's your poster up there with the words on it? The words can be points.
Ooh, I love that. So my quote on the wall, if I were to draw a line through those letters, which would be points, they would be collinear. Very good. I love it. Ooh, I was really thinking outside the box. Very nice. Sometimes my daughters, like I give them Cheerios to snack on, and sometimes I like to line them all up in a row. Those Cheerios would be collinear, right? So anytime you line anything up in a row, it would be collinear. Okay, next word is, oh, sorry, I want to show you what collinear does not look like, because it's nice to see what it looks like, but it's also nice to see what it doesn't look like. Oh, maybe not. I'll have to draw it myself. G, H, and let's draw another line through here, and C, that's what not collinear would look like. Could you draw a line through all three of those points without bending the line? No, you couldn't. So that's what not collinear looks like, non-collinear. Coplanar, I know someone had this one. Here we go. Coplanar, come on up. Jacob and Chris. Coplanar goes right along with collinear. Collinear means same line. So coplanar means same plane. Yeah, it's not rocket science. Collinear, same line. Coplanar, same plane. We can go back to things in our classroom for a real world example. Everyone look at the ceiling. Do you see how every light is in the plane of the ceiling, right? So you can just say the lights in your ceiling, those are coplanar. They're not collinear, because I couldn't draw a line through them, but they're all in the same plane, so they are coplanar. You have another one? Pictures, you hang them up on the wall. That wall is your flat surface, so those pictures could be coplanar. Very good. Yay. You got another one?
Smartboard.
Well, yeah, my smartboard's a plane, so anything I choose to draw up there is going to be coplanar, because I'm forcing it to be on the plane of the smartboard. Cool. I like it. Y'all are thinking. Okay, what would it look like to be not coplanar? So I could draw myself a little plane, obviously, and I could put my dots in there, and then I could put B. Aww, he didn't get invited to the lunch table. They're all hanging out together, and then point B is not with them, so he's not coplanar. Does that make sense? He's not in the same plane as E, D, and A. Okay. All right, everyone else will go tomorrow because we're going to be done with vocab for today. That's enough vocab for one day, don't you think? So let's go to page 2 of our notes. Yep, where it says point, line, plane, postulates. You see that? Cool. We are going to talk about 4 postulates. How many? 4 postulates. These are the building blocks of geometry. Like literally the foundation of geometry. So these postulates are very, very, very important. So that's what we're going to focus on for the rest of the lesson, and then I will stop talking. All right. How many points create a unique line? So what I'm going to do is I'm going to move these around. I'm just going to grab 1 point. We are only going to focus on this guy right here, this guy. Okay? How many lines could I draw through that point? How many lines? 2? Infinite? How many lines? Could I draw through that point? How many? 1, oh sorry, 2, 3, pretend, 4, 5, 6. What number would I stop at? When would it get too crowded? Do lines have a thickness? No. So how long could I stand here? For the rest of my life. So how many points can I draw through one? How many lines can I draw through 1 point? Infinite. So 1 point is not going to create a line. It's not. There's way too many lines I could draw. What does that look like? Those dandelions that you blow, you know, from like the yard, the weeds. Anyways, I think it looks like a dandelion. All right, so 2 points. If 1 didn't cut it, let's see if 2 will cut it. How many lines could I draw through 2 points? 3? 1? 0? 5? Infinite? What do you think? Here, let's force this one instead of me drawing my own line. Okay, so I drew a line through those 2 points. Could someone else come draw a line that's not on top of my line? And it goes through both of them? No. So how many points create a unique line? 2. Yeah, 2. It takes 2. Have you ever heard that song? It takes 2, baby. Okay, I'll play it for you tomorrow. All right, 2. It takes 2 points to create a line. Through any 2 points, there's exactly 1 line. So write it down, guys. That's postulate number 1. These are the building blocks of geometry. It's already the whole word. The pictures are there, but can you write like that? What's in the dotted lines? Could you write that, please? Through any 2 points, there is exactly 1 line. So I did draw the pictures for you already. Through any 2 points, there's exactly one line. It takes 2. 2 points to make a line. It takes 2. Cool? Let's move on. Postulate 2. My question for postulate 2 is, what do you get when 2 lines intersect? Okay, so I have a line, I have another line, and they meet up. They meet up. What do you get at where they cross? What would that be? A point. Y'all are too smart. You already knew the answer. When 2 lines cross, you don't get a plane, you don't get another line, you get a point. They cross at one location. That's what a point is. It's a location. So, it's really common sense, isn't it? If 2 lines intersect, they intersect in exactly 1 point. Goodness, that's easy. We can handle this. You're in math class and you haven't touched a calculator yet. Isn't that crazy? Welcome to geometry. We'll do calculators later, I promise. Just in case you missed it. If they intersect, why would I put that? Why would I have written if they intersect? Do they have the option? Are there lines out there that never intersect? What are they called? Parallel, or do you know what this is called? Not perpendicular, because they're not crossing. Bonus points if you know what this is called. We'll learn about it tomorrow. You can just think of it overnight, what this is called.
Overlapping.
Not overlapping. They're not touching. These will never intersect, and they're parallel. I agree. These will never intersect either, but they're not parallel. This one goes this way. This one goes this way. But we'll talk about it tomorrow. Don't worry. All right, ready? Postulate 3. Go back, sure. Maybe. Sure. All right, postulate 3. Well, we already talked about when 2 lines intersect, you get a point. But what about when 2, don't say it yet. What about when 2 planes intersect? What would you get? When this side of my classroom intersects the ceiling, do they touch at a point? Do they touch at a line, or do they touch at a plane? A line, the crease, right there, like the molding. If you put crown molding on a room, that would represent a line. Very good. So when 2 planes intersect, dun, 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 you get in 1 line. If 2 planes intersect, they intersect in exactly 1 line. And the picture isn't showing up on that one. So, plane RST and plane STW intersect in line ST. So here's where they're intersecting right there. See that? Line ST. That's where they intersect. 3 down. How many to go? 1 to go. We're almost done. Y'all are doing great. How many points create a unique plane? Okay, so we decided that 2 points create a unique line, but we need to know how many points create a unique plane. So I need 4 volunteers to come up here. Stand right at the front. Stand by this table. I won't use you quite yet. Savannah, come on up. Come on up. Yep, come on up. 2 more. 2 more. I need 2 more. Come on. Yes, thank you. 1 more. You don't have to talk. You don't even have to talk. I promise. You don't have to write anything down. You do help him. Shoot. Shoot. Oh, score. All right, ready? We're going to start with 1. We're going to see if 1 point would define a plane. So come stand right here. Here's the plane. You're the point, okay?
All right.
How many planes could I put through this point?
None.
How many? This one, this one, this one, this one, this one, this one. That word that starts with an I. Infinite. I could put an infinite number of planes and definitely go through that point. I could sit here all day and twist this and show you all different planes. So 1 is not going to cut it. Let's try 2. Come on up. Just stand right by him so the class can see. Perfect. Put them close enough where I can reach them both. Okay. Boom. There's my plane. But can I rotate it and still touch both of them? Does sound effects help? How many planes can I put through both of those points?
2.
How many? This one, this one, this one, this one, this one, this one, this one. That I word again. Infinite. I could put an infinite number of planes and still touch both of those points. I'm marking up my paper. Okay, let's try 3. Let's try 3. I don't care. Ready? Boom. Okay, it's touching all 3. Now I'm going to start to rotate it. You can see. Ready? I'm going to rotate it. Uh-oh, what happened? I lost a point. I'll go this way. I lost a different point that time. I'll go this way. I lost a different point. Can I rotate this without losing a point? So how many points does it take to make a plane? How many people are holding pens? It takes 3 points to make a plane. Sorry we didn't use you, but I wanted you to come up there so they wouldn't know right away that it would be 3. Thank you guys. Everyone clap for them for coming up here when you wouldn't. Yay. Okay, one more visual I want to show you with this postulate, because I already have this up here. What's this called? A tripod. Now, why does a tripod, why is it called a tripod? Why does it have 3 legs? Why doesn't it have 5 legs or 8 legs or 9 legs?
Because tri means 3.
Because tri means 3. Say it louder.
It's more stable.
It's more stable. Because 3 is the most stable you can get. 3 points make a plane. If I added a 4th point to this tripod, it might wobble. Have you ever sat in a desk at Cy Falls and it was kind of wobbly? How many legs are on your desk? 4. Why didn't they make the desk with 3 legs? Then they would never wobble because all 3 could touch the ground at once. Sometimes you're sitting in a desk and 3 of them are touching the ground, but the 4th one isn't touching, and that's why it wobbles. So hopefully when you try to remember this postulate, I hope you'll think of a tripod, and then it has 1, 2, 3 legs, because 3 is the most stable. 3. And I don't know why it's doing that. Through any 3 non-collinear points, there's exactly 1 plane. Now, there is one tiny little caveat to this postulate. Why do they have to be non-collinear points? Give you a visual. If I took those same 3 points that those people were holding up, they were holding them like this, right? But if I put those 3 in a row, could my plane then start to tilt again?
Yes.
Yeah. So they do have to be non-collinear. So that's a little picky. We're being kind of picky. Okay. Do you have this picture in your notes? You see it? Examples? Yeah. All right. So all we have to do now is answer, are the 3 points collinear? And if they are collinear, we just name what line they're on. So, Jessica, what do you think? Are E, F, and P collinear? You can look at your paper because it's hard to see that diagram from where you're sitting. Are E, F, and P on the same line or not on the same line? What do you think? Yes or no? Oh, sorry. Jessica, sorry. Alexa. I'm learning. What do you think? Yes or no? No, they are not collinear. Everyone put a big fat no. Do we have to do anything if we say no? No. All right, Chris, C, E, and F, yes or no?
Yes.
They are collinear. Very good. And what line do they lie on? You can call it CE. Someone gave that suggestion. You can call it line CE. Or we could use that, remember the cursive one that's kind of weird? Yeah. Or we could call it line italicized M. Draw it kind of slanted. You don't have to use both. You can use either one, but I wanted you to know both ways. Okay, Zaya, what about E, D, and P? And y'all might be a little confused when there's no dot, but you know if there's no dot there, it's where those lines are crossing. So that one's D, and that one's E. It's where the lines cross if there's no bolded dot. So are they collinear? It's a yes or no question.
Yes.
Are you stretching? Yes? They are, yeah. Name the line, please. Name it however you want. What? ED. ED, sounds great. She picked 2 points that were on the line, and you put capital E, capital D with a line on top. What's one more way we could name that line? I think it's actually an L, but it kind of look like an E. But yeah, line, and then cursive L. Yeah. I think it's an L because L-M-N. Yeah. And there's an uppercase E, yeah, so they probably wouldn't do that to us. Uh-oh, what's this called? Starts with a C. This just from algebra. Coordinate plane. Oh my goodness. We have to use that again? What? So what I need you to do is plot those points. And we're going to find out which three are not collinear. Hey, y'all want to save time? Stop. You guys do A. 'Cause that's a lot of, we don't want to plot that many points. You guys do A. You guys plot B. You guys plot C. And you guys plot D. And we're going to see which one creates 3 points that are not collinear. So only plot the ones that I assigned you. Because I personally don't want to plot 12 points. Right? I only want to plot 3 points. So next to the one I assigned you, I want you to write yes or no. Lillian, A, were those collinear or not collinear? Yes or no?
Yes.
They were all in a row. They totally were. So that's not our answer. Brianna, what about B? Did I give y'all B? Okay.
Yes.
Were they in a row or not in a row?
9.
So B is our answer. Let's try it. 0, 0. 1, 2, 3, 0, and
Oh,
5,
I did C.
0. You did C? Okay. So B is a yes. What about D? Carlos, were these in a row or not in a row? They were in a row. Oh my goodness. Process of elimination. What about C? Jose? No. They were not in a row. Let's make sure. Let's see what it looks like. 0, 0, 0, 2, and, 0, 2, and 3, 0. So those 3 points are definitely not in a row. They make an L, but you can't put a line through those 3 points. So our answer would be C. All right, back to our postulates. What do we get when 2 planes intersect? Remember when the ceiling intersects the side of the room, what do you get? A line. So our answer to these questions better be a line because it's asking about the intersection of the planes. So, fab. Oh, fab. You're fabulous. Fab. F-A-B. F-A-B. That is the front of the box, right? That's the plane that those 3 are in. What about E-D-A? So I'm going to shade it to help you out. There's fab, and here's ETA. Fab and ETA. What do you get when fab intersects ETA? What line? What do you get?
Line FA.
FA or AF, because remember, we can name it either one. Here's where they're touching. Do you see where they're touching?
Okay.
It's where they touch, yep. Where does purple touch the red? So your answer could be FA with a line on top, or your answer could be AF. You will get points off if you don't put the line on top, so make sure you put the line on top, please. Try 2 and 3 all by yourself. Okay, let's do
Wait,
it.
wait.
Okay, we're doing number 2.
Oh, never mind.
That's
Wait,
okay.
did you get GC?
FHG is the top. Do y'all agree with that? EDC is the back. So where would the top touch the back? Where is the blue touching the pink? EG. The answer is EG. That's where they're touching. That's where the top hits the back. So EG, or you can call it GE, either one. Okay, Jared, number 3. Oh, no. Elijah, number 3. BC, did y'all get BC? I'll give you a little hint. Sometimes when we name the planes, sometimes we use 2 of the same letters. Look, there's a C and a B in this one, and there's a C and a B in this one. That means they have to touch at CV because they both contain CV. So I actually could have solved this one without a picture. Yes, Paige?
Okay, like, what if you're doing like a worksheet and then we do it backwards? Like, instead of putting BC, we do CB.
You can't put it backwards because
okay.
they're both equally correct. Okay. All right, name a 4th point in the plane. This might be even easier than the one we just did. Name a fourth point in the plane. BHF. Perfect. What is it? Say it again. A. We're just completing the plane. We're saying, hey, I know that that's the front of the box, and the letter we haven't named yet is A. Let's all say it together. Look at the next one. Don't say it yet. After I say 3, we're going to yell out the letter, okay? Not yet. This one's kind of tricky. Okay, after I say 3, you're going to say the letter for number 2. 1, 2, 3. Oh, no one knows it. Guys. E, F, B. Oh my goodness, that's a plane that's shooting diagonally through my box. Is that okay with y'all? Look, it's shooting whoosh, diagonally through my box. So what's the fourth point? Do you see? Do you see?
C.
It's C. Yeah, right there. There it is. That is the fourth point in the plane. The answer is C. All right, let's try again. A, D, H. Uh-oh, now we're shooting the other way, and I think it's going to be easier to see this time. A, D, H. If I were to connect the dots, where would I touch? Where would I go? G. Look. Now do you see the plane shooting through the box? That one's easier to see. Whoosh, karate chop, slice through that box. All right, are we almost done? Exit ticket. Whew, we made it to the end. State the postulate that goes along with the picture below. Actually write it out. That's on your warm-up sheet. That's on this one where it says exit ticket, where you wrote what you're going to do in 10 years. And then I am done teaching you the lesson.